Well, let's go live. Let's go live. Let's go live. Hello, 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 hello. Hi, everyone. Good morning, good evening, whatsoever time zone is. Um, Firstly, a quick thing. How many of you solved question number two? I just want to know that. Like, legit question number two was it. What I thought was question number two is much harder than question number four. I don't know, question number one, three, four, super easy. Like fourth is actually a medium, easy to medium problem, not a hard problem at all. But second was out of this world, like as in I will put that in a medium to hard category for sure. It was, I don't know how come, maybe people might have solved it. We have Anirudh. Hi. Note done. We have Anirudh. Like, whosoever folks are joining in, can we please have like how many problems you guys solved, what you did, especially if you solved question number two or not, that would be great. And soon, very soon, we will be starting. Just in 2 minutes, we will be starting off with the problems itself. Before that, if the folks have joined in and are watching, can we please smash that like baby and reach to 10 likes? That would be great. And I will not waste much time, because for sure question number two will actually take a lot of time. Because see, what I realized in question number two was many people just assumed and stated many things, although at first glance I could not solve question number two, but I had a bit idea, okay, what could happen, what could I try, still nothing worked out. Then ultimately, okay, I took help of that solution page. From that itself, and nothing was clear at all. But there was one guy, Jeffrey, something like that, NF8 something. He actually like explained it pretty well, which actually, okay, that's not entire explanation, for to be frank, but yeah, it is actually a 60% explanation which you could assume and you could have. But for sure, the problem was amazing. Question number two was amazing. Like question number four, very standard, a robot problem. You have to use a stack and stuff. Very standard. It's a, as in the last to last stream also, I showed you one ant robot problem, right? I just in that I explained, okay, that robot problem have a slight modification. This is one such modification of that robot problem, which we show. Okay, the robots are colliding. When they have to rebound back, we just assume they just pass by. We saw this problem in the last or some stream. In that stream, I stated that robot have another modification. Okay, what if one robot is colliding, it's dead, another robot is coming up, then it's maybe energy or maybe the momentum of the, or see here in this example the health was being impacted. But what if I ask you, the velocity is being impacted, the directions is being impacted, and maybe I just place a wall in the ends also. That's also a standard problem which is of robots. So that's like robots, ants, you can replace any, vice versa. But yeah, that is such kind of problems which you can expect in these kind of problems of robots and all that stuff. Cool, let's quickly start with 134 submitted question 2 at 9:30. No worries. Cool. उसके चक्कर में पूरा contest बिगड़ गया. That happens, yeah. Cool. Before that, we'll just very quickly starting off with the question number one. But before that, can we reach 15 likes? 15 likes, that would be great. Our folks are watching and not liking. We will go, see, as we have been going in order. Question number 1, 2, 3, 4. For sure, 2 is coming next only, right? And also, for the folks who want the notes of question number 2, I have provided that in the description below. So notes, you can also check them out. Entire explanation, I will explain the entire stuff right now also, but yeah, notes are also available down below. Cool. Let's quickly jump on to question number 1. Number of beautiful pairs, and for sure, is the stream okay today? I realized the issue in yesterday's stream was my laptop was overloaded and it could not handle much task. So at every 8 hours or so, I have to restart it so as to remove the entire cache and stuff. Although it has SSD, it has 16 GB of RAM, it has very good processor, very great graphic card. Still, who knows, God knows what happens with this. But yeah, cool. Let's quickly, before that, can we please reach 50 likes? That would be great. Number of beautiful pairs. It's a pretty easy question. What it says is that, okay, you are having a 0 index integer array called as nums, and a pair of indices I and j, where I and j is, okay, some numbers in that nums is called as beautiful. Okay, this pair is called as beautiful of I and j is called as beautiful if the first digit of my nums of I, okay, I just take my ith index in that number, I just take the first digit of that number and the last digit of the nums of j, which is the other number I choose. Okay, if they are co-prime, which means when I say co-prime, their GCD should be 1. If it is the case, then okay, it is actually a beautiful pair and I have to find all such pairs. Constraints are pretty less. I can find all such pairs in O of n square, and to check if that pair is actually a beautiful pair or not, I will just go, okay, and now I know, okay, one number is there, one number is this ith, which is at the ith index, one number is at the jth index. I have the nums of I have the nums of j. I can easily grab the first digit of this nums of I by just converting this nums of 1, which see, it is an integer, right? I will convert this number into a string and I will just simply get, okay, what is the first character of this particular string, which is nothing but, okay, s of 0, right? I just got this first character, I convert that back to a number, which means integer. Okay, now I got the first number itself. To get the last digit of nums of j, you can simply divide by 10 also, or simply modify that to string, get the last character of that string. You can do anyways. Here also it's not required to convert that to string. You can also get the first character, which means the first digit of this nums of I, by using, which means, okay, you have to count, okay, what is this length of this particular whole stuff, which means nums of I, then divided by 10 power that length. Simply you can get that also, but yeah, easy way, fast way, whatsoever comes to your mind. It's an easy problem, so whatever comes to your mind, just quickly write that down. Nums of I, convert that to it's an integer, convert that to a string, getting the first character of that string, convert that first character to actually integer. I have got the first digit of my nums of I. Similarly, I will get the last digit of my nums of j by simply dividing by 10. Now I will have the last digit of my nums of j, let's name it as d2. Here I have d1. I can simply apply a formula of GCD by saying, okay, GCD of d1 and d2, if it is a 1, then my I and j pair is actually a beautiful pair, and I can go on for all those n square I and j pairs by simply do for loops. By that I can simply solve this problem. So first question, very easy. It's simply whatsoever comes to your mind first. See, this question can be implemented in super many ways, but whatsoever comes in your mind first, please just write that down when we have these kind of questions, right? Now let's quickly jump on to the code. It's pretty easy, very easy. I'll quickly show you the code down. Yep, correct, tap. Cool. Now it's simply, as we go on, we have the answer, and okay, it's not the first question. Yeah, first question is this. Okay, we have this nums. Now I just go on to every of those. Let me quickly zoom it. Now I went on to all these n square pairs. Is my screen visible to everyone? Yep, it is. Now I just go on to every of those n square pairs, and I just say, okay, I just converted my nums of I, converted that to actually to get that into a string. Now as it is converted to a string, just getting the first character of that string and then converting that to actually a number back by subtracting that character, and thus I have that first digit, okay, of nums of I. To get the last digit of nums of j, simply mod by 10. You will just simply get that last digit of nums of j. Then just do a GCD and see, okay, if it is a 1, then that pair of I and j is a beautiful pair. So simply increment my answer, and that's I can simply return my answer. Cool. Let's quickly jump on to question number 2. That's again a beautiful problem, but yeah, before that, can we reach to 20 likes? At 20 likes, just one more, that would be great. That would be great. We can quickly jump on to question number 2, but before that, if we have any other issues or something, can we just quickly write that down? No, done. Yes, hi bro, hello Akash, hello non-CSE software developer, hello Anirudh, hello Rupankar, uske chakkar mein pura contest bigad gaya. Yeah, that happens. M Shrikant, hi bro, hi. Weber 1 and 3, no worries, we'll see 4th, although 4th was very easy. Or no, I should not say easy, but it's a standard problem. So if in today's video you see 4th, So please make sure that, okay, next time such kind of question comes in, ants are moving, animals are moving left to right, like this kind of stuff, colliding, all that stuff, then as in the last video also we showed and told, okay, if this problem comes in, we have, okay, the robots are colliding and they are passing by. If they are just reversing the direction, we can assume they are passing by. It is one such concept we learned in the last to last contest. Now in this contest we will learn, okay, if they are colliding and health is being decreased, or maybe energy is being decreased, or something like that, okay, how and what thing we can do. It's a standard, very standard problem, very standard problem. Cool. Web of 1.3, cool. Fourth is just a modification of asteroid collision. Yeah, ant collision, asteroid collision, there are many variations of that. So that's the reason I said, okay, it's a very standard problem. Cool. I solved only one after contest. Third one, no worries. Rohit. Abhinav Garg submitted question number 2 at 9:30. No worries. Anirudh first 1, 3 and 4. No worries. Non-serious for videos. Bro, thank you so much. Vaibhav, I'm also addicted to you guys. Vaibhav first and third. No worries. Vaibhav done. Cool. Submitted question number 3 at 9:30. See, question number 3 at 9:30. No worries. But question number 3 was actually super like standard itself. I'll say that for the question number 3. Because it has occurred many times like that question, so it should be very fast. But yeah, if not, then we know right now, okay, see, some kind of question that occurs, that pattern occurs again and again, that becomes a standard thing. So you have to just figure out, okay, it is standard, it's a standard. So that standard thing you have to figure out. Cool. Will you start Saturday? Rating go jata hai and Sunday fir niche aa jata hai rating. Okay. Yeah, that happens. But Saturday rating आगे जाता है and Sunday फिर नीचे आ जाता है ratings. Cool. Third one was too easy. Yeah, cool. Super sir. Hi Christian. Hi Shiansh. Hi Nagendra. Hello. Anant. B में दिमाग खराब कर दिया. That is correct. B, according to me, B was much harder. Much harder than question number 4. Cool. Can you give similar question of list of question number 4? We have to figure out, but if anyone has watched that stream in which we had a robot problem in which the robots were just passing by, can you please write the name of that problem, which means that lead code number of problem and the name of the problem in the chat. That will be very helpful for all the folks. Hi bhai. Hi Shriyansh. Chandresh, only first, no worries. Please provide link to problems similar to 4 to 1. I'll be very helpful. I'll try to figure out what's the other problem for that. But yeah, as such, I have not collected all of them because I didn't knew that it's a very great and commonly occurring stuff. But yeah, cool. Hi Kushagra. Hi Sarthak. Hi Codewell, bro. Cool. Let's quickly jump on to question number 4. Question number 2. Sorry. I see this question and just it feels like it's the question number 4. But cool. Before that, can we reach 25 likes? Just one more like, 25 likes, please. Minimum operations to make. See, in this you will have many doubts. I myself had when I was, see, as I started with the problem, I had, oh bhai, why this? But please maintain what I am. I will tell the explanation of everything. Even if a number is being used now, I will just say, okay, this is used because of this. It is used because of this. The proper intuition will be being built. So please, if you don't understand this, firstly, you will understand this. You have to listen it daily. And also, if you don't understand this, then please, I'll just try and suggest, do a small, like reverse back, go a bit back and then start again. Then it will be very helpful because it needs quite a lot of mind. Like legit. For question number 4, I will never. For the upcoming question number 4, I will not say this stuff. It's very easy. Question number 3, it's very easy. But this thing, it needs quite a lot of mind and presence of mind also. Cool. Minimum operations to make the integer 0. Now I am having, problem is very simple. I am having 2 integers, nums1 and nums2. Cool. In one operations, I can choose an integer I in the range from 0 to 60. Okay, I can choose an integer I in the range from 0 to 60 and subtract what? 2 raised to the power I plus nums of 2 from nums of 1. Okay, return the integer denoting the minimum number of operations, which means minimum number of subtractions. needed to make nums of 1 equal to 0. So from nums of 1, let's name this entity as x. So from nums of 1, I need to subtract x, where I is something, okay, then x2, then x3, and so on and so forth, such that it becomes to 0. Or I can easily say the same stuff as, okay, I have nums of 1, I have to make it equal to, I have to do x1, x2, x3 up to so on and so forth, such that it becomes equal to nums of 1. I can write it anyways, right? Cool. It is the problem. Example, it won't help you at all. I'll say, it won't help you at all. Constraints will help you, but examples as it is just showing, okay, it's a blunt picture right here. It will not help you that much. Cool. Now, if I have a nums 1, with me, now I know, okay, I have the nums 1 and my x, I represent that x as something as 2 raised to power I plus nums 2. Now, I is something which is variable, but nums 2 is something which is same right now. Here in x1 also, nums 2 will be there, x2 also, nums 2 will be there. But yeah, in this x1, I will have a I1, I will have a I2 here, I will have a I3 here. So basically, the i's are being changed, but yeah, that nums is still there. For that, okay, now we know, okay, I have this nums 1, I have to use these particular x's and make something like this. So I can simply write this same stuff and say, okay, now I just said, okay, it will go on up till where? Let's imagine the operations needed, although it's asking for the minimum of operations, but yeah, I don't know how many operations are needed. I assume the operations needed are k. Let's imagine the operation needed are k. Now, so for our use case, I imagined, okay, number of operations needed would be k. Don't know what it is. Don't know if it is minimum, maximum. I just assume, okay, it's a number which is k. Now, in k operations, I have to, as you showed, I have this x1, this x2, but yeah, as I showed you, okay, I have k operations. So I will have up till k. So it will be, okay, I1, I2 up till ik. I will have it, I have to make it equal to nums of 1. That is so far up till, okay, I have x1, x2, x3 up till xk. Then x1 is nothing but nums 2 plus 2 raised to power I1. x2 is nums 2 plus 2 raised to power I2, and so on and so forth. Now, that ultimately it will, let's just a second, I quickly turn off the settings. How that can be done? Okay, net is off. Cool. Now, what we have is x1, x2 up till xk, right? Now, nums 1 will come in, okay, it has nums 1, I can again write that same stuff as, okay, k into nums 2, because I know nums 2 is repeating k number of times, and then this part, I just write that as separately, because I am trying, okay, my ultimate aim to know is what is the k operations, so that ultimately if I know, okay, my operations are k, now I need to reduce those number of operations needed. Right now I'm just blunt, okay, how many operations will be needed, what operations are there, but yeah, I just assume, okay, it's just k operations which I will need to make my nums 1 to make this particular stuff equal to my nums 1, and that would work. So you also remember one thing, that your all the i's are in the range from 0 to 60. It is just a constraint, okay. I'm not saying the k is from 0 to 60. I'm saying, okay, all your i's whatsoever I1, I2, Ik is being used, that value I1, I2, Ik, that is from 0 to 60, not your k. Please mark my words. Please don't get confused in any part. I'm saying your I1, I2, I3, Ik, all these will be into range. Although it's not much helpful, but yeah, still I showed you. Now, ultimately what I wrote here is I just brought, now I need to actually analyze my k, right? Now, I can just bring it down. Okay, this is particular constant stuff. Nums of 1 is there. So I have my nums of 1 minus k into nums of 2. That is same stuff which is on the right hand side. That's the same stuff right here. Now comes the interesting part. Now you have to analyze, okay, what is the possible value of k right here? So firstly, I will try on all the possible values of k, but when I say I try on, I will start from the possible value of k as 0, but how far should I go? How to know that part? To know that part, for sure, you remember one thing. Just forget this part right now. You remember one thing, okay, your nums of 1 is up till 1e9, which means your nums of 1 is a 32-bit integer. If your nums of 1 is a 32-bit integer, which means that nums of 1, it can be represented at max in 32 bits, and you are subtracting something, which means reducing the value, and it for sure this it can at max go up till 0. It can't go negative. Why, Aryan? Why can't it go negative? Because for sure in the right side you have something which is positive. So for sure this thing, it can be at max from 0 to 199, right? This part, left part, it can at max be from 0 to 199. Why at max 199? Because nums 1 is at max 199. So for sure, you know, okay, your left part, it can have, as your nums 1, it can have at max 32 bits. So your left part, it can have at max 32 bits for sure. Now when I say 32 bits, I just means 32. It can be represented in a 32-bit integer, right? 32-bit integer. So at max, and when I represent a number, a 32-bit, when I represent a number in the binary representation in those 32 bits, I can say, okay, for every corresponding one, when I say one, it's a binary one. For every corresponding one, I can write a 2 raised power something like that, right? So for sure, if this number is it in the range of 32 bits, I can try for at max 32, because see, I just wanted to try for all the k's, right? I just use k operations. I showed you I will try for every possible k. Every possible b means, okay, the k will start from 0 and will go up till some value. Some value, what value? I just figure out, okay, my nums of 1 is at max 32-bit integer. Okay, that range, it can be at max 199 or in the range of 32 bits. So for sure, I can have at max 32 bits as set. So for every binary one, I can have a 2 raised power I, which means at max 32 k's will be there, which can actually solve my answer if it is solvable. Now, if it is solvable, cool. So right now, I just have one thing, okay. I will try my case from 0 to 32 inclusive, right? It is out, okay, what my k I can try out to be. Now, okay, I just right now know I want the k to be tried out, but as I try out every k, okay, I will try out k from 0, 1, 2, 3, up to so on to 32. Now, as I'm trying out for some particular k, how to know that that k is valid or not? How to know that that k is valid or not? Which means I will just randomly choose any k, because I'm trying from minimum k, and as soon as any k satisfies the condition, then okay, it is good k. But how to know that, okay, it is satisfying some condition, okay, it's a good k or not? To check that, okay, that k is a good k, so I have to try out something. What to try out is the biggest question. Now, the thing is that if I just put in, and I take the random example, I'm just going on to every k, which means 0, 1, 2, and just see, okay, this particular k, is it satisfying condition? Condition as in what? So I have to look at this particular equation back, which I wrote above. Now, if I place in a k as 2, I just arbitrarily am placing a value as 2, and I'm trying to figure out, is it possible to place this value here or not? So as you know, for your case, you know nums 1, you know nums 2, as in you choose any of the k's. Now this equation, you know right now, for sure you know one thing as target. You know k, you assumed 1k, for sure you are trying every k out, which means from 0 to 32, so you assumed 1k. You assumed 1k, you know nums 1 for sure, you know nums 2 for sure, you know this value because you assume something as k. Now you know this target value. Cool. Everything has a value right now. This nums 1 has a value, k has a value 2, which we had wrote down. Nums 2 has a value, which we have already have. Now this number as target will have some value. This thing I know also for sure, k is actually 2 because we assume something, k is 2. So for sure, 2 bits will be there, which I can represent. So it is a part, okay. 2 bits, when I say, it can be 2 raised power 1, 2 raised power 2, something like this. Now, I have the right part, I have the left part. I have to make a condition that I choose a k. Now, please validate that k. How I can validate my k? How I can validate my k? I can simply validate my k by, okay, by knowing the right part and by knowing the left part, because the target is being formed, and for the right part, I know I will have 2 bits. I will have 2 bits because k is 2. I will have 2 bits. Now that comes the interesting part. If you had the target number, that target number and you choose 2 bits, for sure you are assuming that okay, you have 2 bits set. If your target number is saying okay, my bits are actually, let's say B, and I will take the number as example. I am saying okay, my K has 2 bits and my target is saying, my target which is being formed by all these numbers together, it is saying I have 1 bit or 2 bit, which means less bits I have. Then for sure it's good. Now you say, Aryan, why it's good? I'll show. But see, when I say it's good, it means okay, your K was 2. So your K, it can be 2 bits, right? 2 raised to power 1 plus 2 raised to power 2, something like that. See, right? This right part, it can be something like that. So it can be 2 bits. Okay, your target is having 2 bits. That is valid. Okay, it can have a 1, 2 bits. What if your K is 2, which means you have K is 2, and it is both are same, 2 raised to power 2 plus 2 raised to power 2, as you saw in the example itself. In the first example itself, it was something like this, a 2 raised to power 2 or 2 raised to power 2. So it can be same also. Then I can transform this back to a smaller number, which is 2 raised to power 3. As simple as that. So I transform this to a 1 bit. It will be a 1 bit, right? So now you saw, if you had a K, you can reduce your K, and that can be formed as a target. But let's say if I go vice versa, I assumed my target had 3 bits, and I am assuming okay, my target has 3 bits, which means let's say it is made by 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 3. Let's say it is made by this. Cool. 2 raised to power 3 plus 2 raised to power 2 plus 2 raised to power 1. Right? Let's say it is made by this. Now, I am saying okay, I assumed my K as 2. Which means I'm assuming that minimum operations required are 2. So for sure, take anything out. Okay, 2 raised to power 2 raised to power 1. For sure, one thing. You assume that okay, minimum bits required for you are 2, but I can easily see that my target formed has actually the number which is being formed after placing in has actually, the number formed is actually this number called as target, and the minimum bits it need to have is 3. If the number is, let's say, and when I say a number, I am representing every number in the binary form. So that number formed as target is, let's say, this, right? 1, 1. Okay, let's say it is 1, 1, 1. Cool. It is the number as 7. So for sure, if I choose my K as 2, it can't be possible because my target number formed has 3 bits. I need to choose more than 3 bits for sure. So K as 2 will never work because K as 2 is saying, okay, I only require 2 bits, which means I can just solve it by writing 2 raised to power something I1 plus 2 raised to power something I2. And that would work. By this too, I'm saying this, that these 2 things would work. But my 3 bits are saying I for sure need a 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 0. And these are different for sure. So this, considering, okay, I consider only 2 bits, won't work at all. I would need 3 bits. So for sure, if your target bits, see, when it's the reason I said, why this question is important is you transformed, you just place, okay, I just choose some K value, that K value is nothing but, okay, what is the minimum number of bits I am considering now, which is the operation itself ultimately. But yeah, if I choose this K, this number as target is being formed. For this number, I will just ask him, hey, what is the minimum number of bits you require? I can get that. And what is the maximum number of bits you require? Minimum number of bits this number target require is the actual number of bits in its binary representation. If I represent this number as binary, let's say the number is 7. If I represent this number in binary, it is 1, 1, 1. So minimum number of bits required to represent this number as 7 in binary form will be actually 3. It is a concept. Please remember, minimum number of bits required to represent this number in the binary form will be 3. Maximum number of bits required to represent this number in the binary form, and when I say 3, it will be nothing but a 2 raised to power 2 plus 2 raised to power 1 plus 2 raised to power 0, which means a 1 0 0, a 1 0 and a 1, which means 3 such I will require a 2 raised to power things, right? It is a minimum number of bits I required. Now, when I ask you to represent that same number 7 as the addition of some 2 raised to power something, the maximum number which you can form is you can simply say, okay, I can transform this number 7 to actually 1 1 ones. 1 plus 1 plus 1, which means a 2 raised to the power 0 plus 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 2 raised to the power 0, which is nothing but 1 plus 1 plus 1 plus 1 plus 1, which is nothing but 7. So for this number target, which was actually, let's say, number 7, minimum I can form out is, okay, when I say minimum in the sense of a 2 raised to the power something, minimum I can form out is nothing but the number of bits in its binary representation. The maximum I can form out is nothing but is its number itself, because writing all the ones down, that is, okay, by this number k, I just know, okay, what is the, and k is nothing but the bits required, because I'm ultimately using this particular 2's, which is nothing but the bits required. So I'm assuming a k. I know that k, it should be at least more than the number of bits of my target, and also less than the number of bits what my target can have at max, which is the number target itself. So coming back, for my number k, I know it should be more than my target bits, because for the number target being formed, because it is being formed, you can't change this number. If you assume the k, then this number is formed already. If this number is formed, it will have certain number of bits. If that bits is actually, let's say, more, so for sure you required more bits. You can't reduce those bits. You can't 2 raised to the power 2 plus 2 raised to the power 1 plus 2 raised to the power 0. You can't transform this to 2 raised to the power I1 plus 2 raised to the power I2. You can't, because for sure you can see it's unique. It's all three are unique. You can't just add them. You can add only the same ones, which means 2 raised to the power 2 plus 2 raised to the power 2. It can become a 2 raised to the power 3. Right? It needs to be same at least, but all are unique. If all are unique, you can't merge them. So for sure, if your target bits, which is the minimum number of bits you require, if you assume the bits required to be, let's say, 2, but the minimum bits required are actually 3, for sure your assumption of taking 2 as the bits is wrong. So it is correct only when you assumed a k as 2 and the number of bits required in the target, it's having, let's say, as 1, 2 or lesser bits than k. Why lesser? As I showed you, if you had, let's say, 2 bits, which means 2 numbers, I can add those and get just 1 bit. So getting that 1 bit is possible, which means reducing the bit size is possible, but increasing the bit size is never. Right? Reducing it is possible, but increasing it is never. Cool. That is a reason. Okay. This is possible. Okay. Increasing this is possible, but that reduction is never possible. Cool. That reduction is never possible, but that increase is always possible. That is the reason I just said, okay, for sure, it is one such condition. And also other condition we showed above only, that if I have a k, for sure it will also have an upper limit. At max, how much I can expand that number. If I have a k, I just can know I can expand that number. How much I can expand that number? I can expand that number to the target, which is the maximum bits it can form. As I showed you, if the number formed is a 7, I can write that number as a 1 plus 1 plus 1 plus 1 plus 1, which is 2 raised to the power 0 plus 2 raised to the power 0 plus 2 raised to the power 0 plus 2 raised to the power 0 up to 2 raised to the power 0, which is writing that same thing 7 times, which means I1 plus I2 plus I3 up till I7. So I just wrote that same stuff 7 times. Now, if I just again ask you, hey, I assumed my k as 8, but the target is 7. Again, higher bit value can't be converted to a smaller one, as we showed here also. Beyond this, I can't write anything else. I can't write a 1 more. As soon as I write a 1 more, the number will again increase to 8. I can't. So it is the maximum I can stretch this number out, which is the target. So assuming 8 bits will solve it, never. 8 bits can't solve it. That's the reason I just know. If I assume the number of bits as k, that number target will be formed. That number target will have what is the minimum number of bits I can choose. What is the minimum number of bits I can form, and what is the maximum number of bits? When I say bits, I actually mean a 2 raised to the power something, a 2 raised to the power I can form. How much? Minimum how many are required, maximum how many I can form. I just choose that, and from that, because ultimately I'm choosing a k which is nothing but choosing that, okay, how many tourist powers I want. So if I choose this, I know, okay, it should be in this range itself. And if it is in this range, okay, it's a valid K. And as soon as I know, okay, if it's a valid K, I can simply say, if that K is valid, which means it should be more than equal to my whatsoever my target formed, its bit count. For sure, it is the minimum number of tourist power I can represent it, and also maximum number is nothing but the number itself, because it's nothing but 1 plus 1 plus 1 plus 1, which is nothing but the number target itself. If it is the case, then I have satisfied my condition of K, and I'm good to say that my K is good. So as you saw, I'll simply I can show that in that also. The notes are down below for this question. But yeah, if the folks had liked it, can we please smash a C? It's not, again, I'm saying it's not an easy question to understand for sure. Fourth one will be much easier to understand in comparison to this, because here there are multiple scenarios of you thinking in the form, what is a tourist power I, why that number, which is K, I have chosen as number of bits to be formed. I converted that to a number itself, then thinking of that number in its binary form and thinking, okay, what is the minimum number of tourist power I can have, what's the maximum number of tourist powers I can have. Okay, it's a minimum, it's a maximum, now I have to place that in the range. So it is all that stuff which you need to think in. So yeah, that's the reason. If although you should be able to get it now that how it is being done, but still, if it is a bit case, then you can just simply go back in the video and simply just have it a glimpse through again. And for sure, just have a peace of mind, sit down and please write on the paper itself with me, just write on the paper itself. Okay, it's a 1 0 0. Okay, number of bits are this. I can't form from more. Let's say if I am using 3 bits in my binary form of target, I can't reduce the number of bits. Please just to imagine this and see, it's one thing, if you will note down right now, it will help you forever. So please imagine, okay, I have this number of bits, it can't be reduced to a lesser number of bits. So for sure, I just want, okay, number of bits to be at least more than this and also less than this, because for sure I can't expand this number of range of target. Cool. If the folks like it, then please smash that like button. It will be super great. From which account you gave the contest today? I didn't give the contest. Today's problem went live at around 9:15 or 9:20ish, which was actually sorry 8:15 or 8:20ish, and then I went on to have some food because I was super hungry in the morning. And then when I came back, I just attempted all the questions in that order. One easily done. Question number 2 I couldn't understand, so I couldn't solve it at that moment, so I just moved on. Question number 3, did question number 4, then came back to question number 2. Still, it was very ambiguous at that moment. Could not figure out the actual logic. I just did a brute like up till, I just went on to this range up till 1000, because I didn't know, okay, what point to stop at. So I just abruptly increase the range, increase anything whatsoever you want. So I just did that, and that's how that was done. But yeah, the actual proper logic, okay, why it is being done, what all is it's being done, that was super helpful. Why that I forgot that guy's name. There was one guy who explained that very well in the discussion. From that I took a help also, okay, because I was confused in this also, because according to me, at one glance I could not solve it. I just used way too many assumptions in this, and that was blind assumptions. I didn't know the proof of any of them. But yeah, now some of them have proof, okay, some are like this. Now because of this some part, you can assume this part, and this assumption, it can be proved vice versa. So all that was done. But yeah, the folks are watching, can we please smash that like baby down if you guys got it, and if you think that you will get it after watching it again. Anyways, cool. See, firstly, we just had it, okay, if my nums1 is already less, for sure I can't add, which means if it is already less, I can't subtract anything down. So for sure I'll simply return a -1. That's simply a case. And then I can simply go on to all my case, although it's not required as such. We can still do it, because for sure that last condition will automatically make sure that we are actually following it, because see, ultimately if it is not done, for sure it can't be done, because the number will be for sure be less. So no worries to take it in that step. So as I showed you that I will go on to every k from 0 to 32, then I will get that diff which is a target. So if that number target which I have, if that target, I will just go and find the bits in that target, because I know my bits of that target, my k should be more than my bits, and for sure my k also should be less than my target itself, as it's the maximum number of 2 power I can form for my number. If it is the case at any point of time, because I'm going on from the least k, right, I can simply return my k itself. Even after trying all the bits, if I can't do it, for sure I can simply return a -1, and that's how I can simply solve this problem. Cool. Let's quickly jump on to but yeah, before that, any doubts in question number okay, I'll quickly turn on. But yeah, any doubts in question number 2, please just write that down. And for sure, can we please reach the like to 35? Just 2 more, that would be great. Just 2 more, that would be great. Sorry, it didn't sync up, and I forgot to actually sync that up. Oh, damn. I have to close it down, yeah. But yeah, meanwhile, if we can quickly, if any questions you guys have or anything like that, just quickly write that down in the chat box, or CP notes, LZ contest, and question number 3. Cool. Let's quickly jump on to question number 3. But yeah, before that, can we reach 35 likes? That would be great. Cool. Let's quickly jump on to question number 3. It's nothing but ways to split the arrays. Am I audible and stuff, right? Yeah. Ways to split the arrays into good subarrays. It's easy. How? We know that by just example. See, many problems are just that by the example itself you can easily get to know what is being done and what can be done. So it is one such thing. There are many problems in which example only is sufficient, right? We are having a binary array nums. Cool. Okay, it's just binary array means okay, it's have only zeros and ones. Now a sub array of an array is good if it contains exactly one element with the value as 1. I can choose a sub array, but it should have exactly 1 times as 1. Exactly 1 time as 1. It should have, right? Now, if then only it's a good sub array. Return an integer denoting the number of ways to split the array nums to the good sub arrays. I have to split the array nums into the good subarrays. Number of ways I have to found. We will see what the example itself, what it means and what all that stuff. As the number of ways it can be too large, return it modulo 197. Cool. And subarrays is a continuous non-empty, all that part. Okay, subarray is something. Now, for sure, as I glance on this number, first thing, I am starting to make the subarray itself, right? I am starting to make this subarray itself. As I am starting to make the subarray itself, for sure, my first subarray, it will start and should at least take at least one of the ones. Now, it has taken at least one, then only it is good. My next subarray, it will start from the remaining zeros and it can take again the 1, right? Now, what if I say, let me quickly change this particular theme, and yeah, 0 1 0 0 1 0 1 0 0 1. So firstly, as you saw how I initially made my subarray, firstly, as I was making one of my subarrays, I started from here. I did not stop until I reach one of the ones, because only then I can make one of my good subarrays. My first subarray will be good only when I have reached one of the ones. Now, I will again start from these zeros. Again, my next subarray needs to have one of the ones. Now comes the interesting part. As you look at the example itself, you will see the first one is the one which we already made by thinking from the problem itself. But as we look on and see, then we will see that, okay, they included this last 0 in this first array. They included this last again in this particular subarray. What it means? It means that, okay, this one is independent, and already I have got one subarray. I have already got one subarray, which is already good. So I can include this zeros in this subarray itself, right? So if I have options to include this zeros into this subarray, so this zeros will help me. When I say these zeros, I mean these zeros will help me to actually say, okay, what all options I have for the new subarrays being formed. Because for sure I know this one can independently also form one good subarray. So these zeros are independent. And for sure, please make sure that at least one good subarray is already being made. If it is already made, now I can just apply to think of modifying my existing subarray. I can't just say, okay, let's choose this subarray because it's already not good. So let's first make one good subarray, and then I had option, okay, just add this particular zero in this, I can make this, add this zero in this, I can make this, and ultimately and also I can't make this because right now in this array I have two ones. I want it at max exactly one of the ones, so I will just make this particular subarray. Now as you saw here, it should have made many things clear out. Firstly was my first subarray. I have to make it and I have to bring it to 1. Now when it has gone to 1, for this next subarray, I have two options. These two zeros, it can actually add in my previous one and make that modified. What if I had again a zeros, right? Again a zeros. Then it can also, see, from this I can make my 3 modifications. How 3? One was this entire stuff. See, because you can think of in any ways. Either you can just make this one as good, or you can just assume to make this one as good. Now, what I'm assuming is it is strict. It is, let's say, strict. Now, for this to make as good, I can either take it as just this one. I can take it as 1 0. I can take it as 1 0 0. As simple as that. Now, when I have 3 options, I have one option to this, one option to this, one option to this. I have 3 options for this. For this particular stuff, I had 3 options, right? When I say 3 options, and when I say I have one for this, or let's say I say one for this, it automatically means the previous, all these zeros, it will go to the previous subarray itself automatically. So I just applied one operation to this particular subarray and asked me, hey, I have option that I can give you the remaining zeros, which means I can be good if I have 3 options. One I choose myself, one I choose the previous zeros, one I choose the other zeros. So again, it has 3 options to actually modify its particular range. Again, it will have 4 options. How 4 options? One for this, one for this, one for this, and one for this. You will ask, Aryan, why not one for this? Because for sure, it will have 2 ones that we can't want. So it can be modified in 4 ways. It can be modified in 3 ways. And for sure, it's just a combination of ways. Once such array is made, if I just modify this up till like this, and then if I can modify this right range in 4 ways, which means I can modify this as 1 and this remaining part is left. When I say remaining part is left, it will automatically attach to the left part, and I can modify it like this. So again, the remaining part will attach to the left part. When I assumed, okay, it is one such way I've modified. So I can modify this range in 3 ways. I can modify this range in 4 ways. So ultimately, I can just simply count, okay, what is the count of this range? It is 3. It is 4. Let's say I go on forward, it's, let's say 5. It's 2. Let's say it's 5. And so on and so forth. I can simply lastly multiply all of this and simply get my answer. Okay, what is all the number of modifications required? And that all, everything, we simply solved it by using this one example itself. You had gone to the next example itself. Now, as we go to the next example itself, you will see, okay, Aryan, it's 0 1 0. I take my first of this subarray. Then shall I take this? No. Why no? Because for sure I asked you, you can take only when you have found one of the ones. So as soon as you find one of the ones, then you can say, okay, this is now the range. Whatsoever number of elements are here, please just bring me those numbers. Now you will ask, Aryan, although you take it as 0, 0, 1, what if a 1 comes here? No worries at all. If the 1 comes here, I can't, it is the only range which I can take right now. 1 came here. Previously, number of zeros are none. So for sure, one group, it can only form like this, intact. It can't go in any other ways. So for sure, it's nothing but a 1 multiplied. Or I can simply skip that 1 also. So I'm only concerned about all the zeros. Ultimately, I'm only concerned about all the zeros up till a 1 came in. Up till, please remember, up till a 1 came in. Because as here you saw, all these zeros are here. But the 1 didn't come at all. So I'm not concerned about it. Firstly, also, please make sure that, okay, one of the groups is already made. If it is already not made, you can't club in the previous zeros, which means because at this particular group, you are just assuming, okay, you had this, then you had this, then you had this. So if you had this particular range, so the remaining zeros will be clubbed in with the previous group, previous subarray, that you can only group in when you actually had a previous subarray. So simply, it is nothing but I will firstly make one of these subarrays, then I will go on and count all the zeros in my next range until a 1 comes in. Okay, I can say, okay, when I say until a 1 comes in, you can just simply count, okay, the number of zeros are 2, and for sure the 1 has came in. So I will just say the number of zeros plus 1, or you can also say, okay, I will count all these zeros and 1, only 1, I will count, and its count is 3. You can go anyways, because ultimately you are only concerned with counting one of the ones, because you have said it's exactly 1 element as 1, right? And I keep on going and counting, okay, for this range, the number of zeros are 3. Again, a 1 found, it's a 4. Let's say if 1 had been there, and again a 0, 0, 0, 1 had been there. So I will just have skip. Or I can simply have a 1, but yeah, simply skip, or simply multiply a 1 for all of them. And then when this 0 is again started, again I have found a 1. Again simply say, okay, multiply a 4 for this. Again, let's say if I have found some zeros, but for this no 1 has ended, so I will not multiply anything for this. So ultimately, as we saw, I can use the existing. See, it is nothing but a permutation combination plus a subarray problem, which is a maths plus subarray. How maths? Because you know that one way you can modify this range in 3 ways. In the right range, you can modify in 4 ways. So ultimately, in total, this part can be modified in 12 ways, right? That is simply a permutation or simply a maths also. That's not a big deal at all. Cool. That is how you can simply solve it, which means ultimately, firstly make this first group. When it is done, then quickly go and count all the zeros until a 1 is you have got. As soon as you have got one of the ones, simply multiply. Let's have the answer variable as initialized with 1, because it can be there. Now, if you have found one of the ones, simply go and multiply the element with 3, then with 4, and then so on and so forth. As you see, find the zeros and a 1. Simply go and count the zeros in the range. Add a 1, you will get a number of that, which means all the zeros, and one of the ones. Simply get what's the count, multiply that count, and simply going on multiplying that count in your answer. Also, please make sure that you are multiplying numbers again and again. That can be a very big number. So please do a modular at every step. I hope that you guys like it. That was actually why I said that it's an easy problem. See, it's easy because it's a standard problem. Using, I'll quickly go back. It's a standard problem. Why I say that? Because it's a range, right? You have to choose such elements that, okay, you have fixed the range, right? Because you know that, okay, in your range, you can choose only one of the number as 1, right? Now at runtime, you can choose to choose only this one or this or this. So as you have already choose a range, so it becomes a problem of a subarray. So basically, you just went onto the array. Now you collected the subarray. after getting the subarray is just counting, okay, just counting the elements in that range and getting that count of elements and then just simply multiplying that. So getting the count of elements, you have seen that maybe you have solved the problem that, okay, I have 0 0 0 1 1 1 1 0 0 0 1 1 1 1. So basically you count all the consecutive zeros, all the consecutive ones, all the consecutive zeros. So these kind of problems are same to each other. That's the reason it is being counted in that same problem itself. Cool. If the folks have liked it, can we please smash that like button to 45 likes? That would be great. 5 more, that would be great. Please, 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 please. Cool. If any doubts, any stuff, can we please write that down? But yeah, can we please, sorry. if you have guys got the logic and all that stuff, can we please smash that like baby down? And also, let's reach to 45 likes. 45, please. Cool. Let's see the answer. Firstly, we have the answer as initialized with 1. It's not important that the answer to always be 1. Why? What if I have all the zeros? See, if I have at least one of the ones, for sure the answer can be 1. But what if I have all the zeros? Then for sure, no such subarray can form, right? So for sure, the answer will be 0. But yeah, I initialize my answer with 1 because I'm going to be multiplying my count in that answer itself. But before that, I just said one thing. Initial all the zeros. I showed you, right? Initially all the zeros I have to complete. I have to go on and remove all the zeros until I land to first one. And also it is also ignored because I'm ultimately concerned about the next of the zeros after this first one. So starting zeros I can ignore for sure because these are never useful for me. So as I just went on and ignored starting all the zeros. Now I am just incrementing my I is just a variable which I have defined above. If this I has reached the end, it means for sure one thing. What? I had all the zeros. Then only I can ultimately reach my I to end. If it is the case, if you had all the zeros, you can't make any such good subarray. All you have zeros, you can't do anything. So for sure return a 0 right here. It's the only condition. You have to return a 0. Now comes the interesting part. Now what you will do is simply it will happen. You will get a 1. You will have a count of my zeros previously. Count of my zeros previously is 0. Cool. Nothing will happen. Or I can say count of my zeros previously is, let's say, 0. And as I showed you, if the count here is 2, I simply added a 1 because of this next one, upcoming one. So the count ultimately became as 3, and I'm multiplying this in my answer as 3. So I can also write the same stuff as, okay, my count initially is 0. I just got one of the ones. I will simply add a 1 because it can form one such a subarray of size 1 also, right? So it is a 1. I can simply multiply this 1, which is nothing but this whole length of 1 itself, into my answer, and that can simply solve it. So basically this particular part will help you. Okay, let's say if you got some continuous ones, it will just say the previous zeros found are actually 0, added a 1 because of this occurring 1, and then I will get a 1 as count. I'll simply multiply this 1 in my answer. So I'm simply going and checking it out. Quickly going back to the code, as I went on to my nums entirely, if I have found a 1, what all zeros I have found so far, it will be stored in my count. In my count, it is storing all the zeros found so far. Now, as it was starting out initially, my zeros count was actually a 0. So it is nothing but I'll simply do a count plus 1, because count is nothing but the 0 count, but the subarray length, it will include one of the ones, right? So plus 1 for one of the ones. And I can simply go on adding in my, multiplying that in my answer, because I know that every will have cumulative effect. Okay, 3 ways for this, 4 ways for this. So ultimately 12 ways in total to make all the different subarrays. And then as my 1 is done, so I have to reset my count of the zeros, as I showed you earlier also, right? If my ones are done, if my ones is done, and if I have got, okay, if I have 0, 1, 0, 0, 1, 0, 0, 0, 1, if my zeros are done, again the new set of zeros is going to start. So I have to reset my count of zeros. It's again gone to 0, and again the count will start, and it will again touch to 3. Right? So I'm just simply going on and resetting my count when I have got my zeros. Else, which means, okay, it's simply a 0, so I will simply go on and counting my zeros. So basically I'm adding the effect of count only when I get a 1. That's the reason. I'm only adding the effect of my count, which means the count of zeros, only when I get the effect of, I get the 1 itself, right? And ultimately at every point I need to increase my I pointer because I'm gonna go to the next element, and ultimately it will just go on and multiply all such ranges from 0 to 1, 0 to 1, 0 to 1, 0 to 1, multiply that, and simply get the answer in your answer. To get all such sub arrays, right? We'll quickly jump on to question number 4. But yeah, before that, can we smash that like baby to 50 likes? Just 2 more. That would be great. I'm super thirsty. Let's quickly drink some water. But yeah, please. We'll also read some comments quickly. But yeah, can we please reach the likes to 50? 100. That would be super great. I got 1, 3, 4, but I think 2 is hard problem to figure out, but your explanation made it easy for me. Thank you, Praneet. But yeah, 1, 3, 4 is actually easy. 2 is actually hard one. That robot question was good. Got a TLE but solved 1 on 3. Robot question TLE, it should not have come. Why? Because that robot question is a standard stack problem. Usually these kind of problems are solved with stack usually. So if the stack thing would have struck your mind, for sure it would have been easy, but cool. No worries, we will see. And see, also please make sure that, okay, in the last to last stream we also solved one of the robot problems in which the robots were colliding and then reversing the directions. So in that we learn the concept that the robots can pass by. Here we are learning another concept. Okay, if I have a robot coming in and the robot going left, then for sure if one robot needs to be destroyed, which means one needs to go down. If it can be this or it can be this, so anyone can go down. So for sure I need to remove one thing. That direction concept is actually used very much in stacks. If you had solved the basic stack problem, which is the parenthesis problem, what does parenthesis mean? It is the left parenthesis, it's the right parenthesis. So basically this parenthesis itself was how much? Was a stack problem, right? So that stack problem to evaluate, to analyze the parenthesis was actually a stack problem previously. So that stack problem, it can actually be transformed and told you by in that form. Okay, right and left. Right and left is actually nothing but a parenthesis only. Right, left. That you can simply think in that form also. Cool. What was that robot problem? If anyone can just comment that down, the problem name, that was great. So basically it was a problem in the last to last contest, or the last to last contest, in which we learned the concept that it should collide in, and if they are colliding in, then they are reversing the directions. We assume simply if they have same velocity and mass, they will just pass through. So cool. Thank you so much for great explanation. Thank you so much, Akansh. That robot question was really no worries. Pabitra, hello brother. Hello. Prajwal, second question was like next to impossible. Yeah, that was correct. I have been coding for a year but still can solve only 2 questions. No worries. That comes, see, by just learning new concepts and also grasping things out. Because see, every time, anytime you learn a new concept, please write that stuff in your notes down. Anything. For me, I make my notes online. I just write there down. For you, if you learn anything concept new, just write there down, right? Cool. Yes, it is similar to previous contest questions. Leetcode really going into ad hoc. So it's good. It's good to go into ad hoc also, and also into DSA. Completely going DSA, everyone will be for sure, because you can't explore much on DSA part. That's the reason I also recommend do also give code forces like a bit frequently, so that you can your ad hoc logic thinking can also build up, because from Leetcode your DSA logic will build up. Ad hoc problems are pretty less, but yeah, ad hoc problems are coming up, so I'm liking that part. But yeah, But if the folks are still watching, can we reach the likes of 55? यार 55 तो कर दो यार, तुम लोग देख रहे हो 35 लोग देख रहे हो, थोड़ी सी शर्म कर लो. I mean, like, that would be great if we can reach the likes of 55. That would be super great, super love from you guys. We'll quickly jump on to question number 4. That would be the last question for us, and that would be great. Let's quickly jump on to question number 4. Right? Let's quickly see the question number 4. Cool. But yeah, before that, can we reach likes of 55? 55 likes, यार. मतलब तुम लोग क्या करते हो यार? मतलब 55 चलता है. Cool. Robots collision. Cool. There are one indexed robots, each having position on a line, health and movement direction. Cool. I have health, I have movement, I have direction. Okay, I have a line, I have health, and I have movement. Movement is in the other direction in which they are going. Now I am also having the... I'll quickly jump onto the explanation and explain the concept itself. We have a health array, we have a directions array, we have the positions array, right? Positions will define for every robot. For this robot at the position 5, my health is 2, my direction is R. The robot at the position 5, my health is 2, my direction is right. My direction is right. For the robot at the position 4, my health is 17, my direction is again a right. Robot at position 4, my health is 17, my direction is right. Cool. My robot at the position 3, my health is 9 and my direction is right. Cool. My robot at the position 2, my health is 15 and my direction is right. It is just showing all these robots. Now ultimately what I am saying is, this is what I'm saying: return an array consisting of the health of the remaining robots. Now what I mean by remaining robots, how the robots will act is, two robots can collide. See, if the robots are moving like this and all the robots are moving in the same velocity, which means the same speed, so the two robots can collide only when they are moving in the opposite directions. Now as the two robots are colliding, so basically the lower health robot will get removed and the higher health robot, its health will get decreased by 1, right? The lower health robot, its health will get, for sure, it will get removed entirely, and the higher health robot, and see, collision will only happen when both the robots are moving opposite. Remember, right, left, right, left. Cool. And the higher health robot, its health will reduce by 1. Now, as we have this health, and what if the health are same? Cool, no worries. If the health are same, they both are removed, both are gone. Now for this example, all the robots are moving right, so all of them will keep on moving right. Ultimately no collision ever, so ultimately all of them will have the same health, and I have to put the health in the order of what they have been. Return an array containing the health of the remaining robots in the order they were given in the input. Please remember, in the order they were given in the input. If I had considered 5th as the first robot at the 5th location as the first robot, so okay, for the first robot at the 5th location, I have the health as 2 and the health will remain same: 2, 17, then 9, then 15, and then 10. It is in the same as the input which was given, in the same order. Now as all of them were moving right, so no collision happened, so none of the robots' health reduced or none of the robots got removed. What if I choose this problem? Please, before that, one thing from this example itself you could infer, from reading the first example itself, you could infer that I had the robots given in this position. I sorted all the robots. I sorted all the robots down. I sorted all the robots down to what? I sorted all the robots down in the order they could be in the x-axis, which means on the basis of their positions. So basically, initially, as you saw the problem, you know one thing, as the problem is also visualizing you, as soon as you got the arrays, positions, health, and directions, you have to sort your input in corresponding to your positions. So for every position, so basically if you want to sort this stuff, either what you can do is put everything in one vector and then sort that vector down, or what you can do is have a vector called as index, which means I will have the index as 0 1 2 3 4 and 5. 0 1 2 3 4. Okay, 0 1 2 and 3, 0 1 2 and 3 and 4. Then what we can have is simply sort this particular input, which was 0 1 2 3 and 4, corresponding to the positions itself, which means as the position is saying. So basically what it will happen is it will sort things down on 4 3 2 1 0. So basically finding answer, when I say I will find answer for 4, it will point to index 4. So I have got the position, I have got the health, I have got the directions. So sort, you can make entire different array. It's just a way to sort, or either one way is you place everything in one vector, positions, health and directions. And then, because see, for sure for every corresponding position you need to keep track of the corresponding health, and you need to keep track of the corresponding direction also. So either you can place everything in one vector and then sort the vector down on the basis of position, or you can have a one vector as the index, which is initially 0 1 2 3 4. Sort this index vector on the basis of the positions itself. Now as it is sorted, it looks something like this. Index 4 comes at first, index 3, then index 2, and then index 1, then index 0. But this I know, I need to operate on the index 4 first, but the values I can get corresponding to the positions itself, the health itself, the direction itself. Cool. Now I have I will sort my input on the basis of my and yeah, meanwhile, yeah, you have not reached the likes of 55. Just one more, that would be great. Cool. Now I have sorted this down. Now as I have sorted down, okay, everything will occur in the order, which means from smaller position to the higher position. Because as I can visualize in the example itself, as I see this robot, as the robots are moving in the right, as soon as the robot coming in the left, it comes in. Now the collision is bound to happen between these two robots. The collision is bound to happen. As the collision is happening, I know I'm concerned about the health only. So health, both of them have the health as same. So both will get removed. But still you can see that this robot is still moving. It is coming in. Then it will collide with this thing. Again, the health is not same. So for sure the lower health one will get removed, and the higher health one, its health will get reduced by 1. So ultimately I will get health as 14. So one very standard intuition which you can get is, okay, I can have a right, then left can come in, then again a right, and then a left can come in, then again a left can come in. So isn't it the same as analyzing the parenthesis problem? Right bracket, left bracket, then right bracket, then left bracket. Same. As the right left bracket came in, I need to analyze this bracket and remove this bracket altogether. So that next time, let's say this bracket came in, I will analyze this and remove this. Next time I can remove this, and next time something again come in, so I can just add that here. So it is kind of visualizing, because see, every incoming left, it can impact a every incoming left, it can impact which is going right. So if it is impacting, which means if both are same, so for sure both are removed, right? What if it has very high health, it has low health, so for sure it will be removed and its health will get reduced by 1, right? But still it will remain. And you remember one thing, if we had going in, we used a stack to analyze it, and that's very intuitive also, because for sure if you have something going in, it will always go in. It can only be impacted if something is coming in. So I can just push these in my stack itself. Okay, it's in my stack. As soon as something is coming in, which means it's coming left, it can impact my stack top. If its health is more, its health is less, so okay, it will not go, and its health will reduce by 1. Cool, its health reduced by 1. Let's say H-1. But what if its health was high, very high? So for sure my stack top will get reduced, and then it can impact the next incoming stack element, which is nothing but this particular stuff. So I can easily see that one of these arrows, as I'm coming to the right, I can push that in my stack. As I encounter anything which is left, I will not push that in my stack for sure. I will just say, do I have something? Oh, Aryan, what if the stack is empty? The stack is empty, which means I have nothing beyond it. It will keep on going in the left, and it will collide with nobody. So simply, its health will never reduce. It's never going to be impacted. So if it is going left, if it is simply going a left, right? So simply keep on going in left. But I am only concerned about, and Aryan, what if it is going in the right? As it was going in the right, you simply push that in the stack. If it is going in the left and the stack is empty, simply keep on going that to the right. Don't worry. If it is going to the left and you already have, and the folks are still watching and they're liking that part and understanding, up till this point, if you know, okay, the stack is going to be applied, I'm going to apply stack, please stop the video right here, live or something like that, and then think, if you can think of applying the stack itself here. Cool. If the folks has still got it, then likes can also be increased. But yeah, if we just have all this stuff, okay, I just want one thing. Okay, if I have a left and my stack is empty, I can simply keep on going my left and its health will never reduce. So I can ignore this. What if I had a right only coming in? So I will just simply place my right in this particular stack itself, because right by itself is never going to be impacted. Right can only be impacted when it has incoming a left. Now, as soon as a left is coming in, I will just ask, here's the stack top. I know my left is coming in. I know in my stack I have only right. Arrows. I know in my stack I only have right arrows. I know I have coming in as left. So for sure, the collision is bound to happen. If the collision is bound to happen, what is your value? If your value is high, which means it is, let's say, h, bada h. If it is small h, for sure that small h is gonna be gone, and its h value will become h minus 1, right? And will still remain in the stack, because for sure anything, let's say any big value, let's say another arrow came in, another left came in, which has, let's say, bada h2, so it can impact this particular thing, right? So cool. But what if, and as I showed you, okay, if it has a small h, if the incoming has a bada h, for sure it will just go away, because for sure it will be destroyed, and which means its health will become a 0. And as soon as the health becomes zeros, we just simply don't return that in our output. As you saw, although you can modify the health, you can just say, okay, your health has become a 0, but ultimately while returning the answer itself, I will say, okay, if the health is something, then only I am considering in my output. If the health is a 0, I will not consider it in my output. So if it is impacting and the incoming is a h, small h, it will just say, okay, please you go away. If it is, let's say again a small h, and please, as soon as you encounter any of these small h's, also make sure to reduce the health of the higher person by 1. It's every time it's gonna happen. Every time it's gonna happen, right? Cool. Every time it's gonna happen. It's just the simple stuff. Ultimately, whatsoever you have, you will keep on modifying the health of everyone, because as you got this particular element, as you got this right arrows, right robots, it just keep on going in the stack. As you got the left coming in, you will ask the stack top, hey bro, what's up? Is your health less? If it is, I will make your health as a 0 and I will remove you from the stack. And why I'm making the health as a 0? Because ultimately I need to return the answer. That answer I need to return, okay, what is the health of all the robots? So I'm maintaining the health of all the robots, and I'm maintaining, okay, what the health you have right now, what's the health you have right now, what's the health you have right now, because it can happen, okay, I can have this right, and it is very high, let's say. So every time the right comes in, its health will get reduced by 1, its health will get reduced by 1, its health will get reduced by 1, its health will get reduced by 1. So it can have that, okay, the same robot can have health impacted multiple times because of multiple rights. But I am encountering every right or every left exactly twice, or at max twice. Left, I just encounter once, and right, I can encounter at max twice, which means while pushing that into my stack or while removing that from my stack. Cool. Now I just went in, and I will just simply say, okay, if I have a left arrow, and I have nothing in my stack, that can simply go in and its health will never reduce. If I have a right arrow, that right arrow can easily come in my stack itself. I can simply push it. Now, if I have a left arrow and my stack is not empty, which means I can impact my right arrow. So I will just keep on asking, hey, if the top health, if it is more than my health, then okay, it's gone. I can simply return and its health will get reduced by 1. But if its health is more, its health is less, I'll simply remove that and reduce my health by 1. I can again go and ask, hey, now you say, what's your health? If your health is also less, simply reduce by 1. Now it's empty. It will simply go on up till infinity, but now its health is also reduced by 2. So it is now h minus 2. It is simply what you have to do in this problem. And please make sure that it's a very standard stuff, that as soon as something is going left and right, something is going like this. So you know one thing. So you should be knowing one thing, okay? Brackets, you can imagine like this. Arrows, you can imagine like this. So it's nothing but the parenthesis problem itself. One thing is impacting another, right? And this next one, which is, okay, this is this, but outer can be there, right? Outer one can impact the previous one. That is why we use a stack. If the folks have liked it, can we please reach that like to 60? That would be great. Super great. Cool. Let's quickly jump on to the code itself. It's pretty easy. I use a stack itself. I have an n. Firstly, I showed you I want to sort my everything down. When I say everything, either I can make a vector, entire vector, or I can use a simple index, which will say, okay, my standard current right now, my indexes are from 0 to n minus 1. I need to sort my indexes on the basis of position, right? On the basis of this stuff, because I need to go from left to right. So I need to sort on the basis of these positions. So I just choose to make an index array, and I just sorted that index array on the basis of my positions itself. So I just choose to take the index array. I just made that index array, and I just sorted that index on the basis of my positions, which is nothing but my v, which is this position itself. Now, as my index is sorted, now I know, okay, I will actually go on from left to right. So I am going on from left to right, right? As I go on from left to right, now my current index, my actual current index. So as I go on from left to right, so basically this index is sorted. This index is sorted now on the basis of this particular directions. So my I, it will point me to this particular 4, this particular index 4, which is saying, okay, it is the first occurrence. It is the first occurrence which I have in my left, right? Now, if I have the first occurrence with me, I simply ask him, hey bro, if you are a left, and also if the stack is empty, no worries, your health will never get impacted. You can simply continue. If you are a right, hey bro, if you are right, then please get pushed in the stack itself. No worries. Else, if you are a else, which means, okay, if it is landing the else condition, okay, you are a left and the stack is not empty, which means if you are a left, you can impact your stack. Maybe you are finished. Maybe your health will become a 0, or maybe you can impact the stack elements. So for sure, I can perform some operations on my stack itself, because of which the health is going to be impacted because of this current incoming left element, because for sure the element will be be left. Cool. As I go into this left element, I will just simply the same stuff which we saw. I will simply ask him, hey bro, are you empty? If it is not, I'll simply go on. And as I go on, I need to know, hey, what is the top element of the stack? And what is the health of that top element? If that health is more, the top element health is more, I am coming as left. If the top element health is more, he will destroy me, but his health will reduce by 1. Although he will destroy me, but his health will like his health, which means right's health will reduce by 1. So for sure, right's health, which means health top will reduce by 1, and my health, which means the left, which was coming in the stack, coming in to actually encounter the stack, it will get health as 0. Now Aryan, health as 0 is never required, so why are you putting it here? Because in the last I will have to output the health of everything, right? So I will not output the health which are 0, as simple as that. So, and again, this right which was coming in, the left which was coming in, it was health was less, so it was destroyed. And right, we popped out from the stack, right? We popped out from the stack, but it was never destroyed, so push it back with the health as -1. So health is reduced by 1, and I push that back to my stack. And for sure, my left is destroyed now. I can't impact my stack anymore, so simply return. What if both have the same health? As we saw, if both have the same health, simply both of them health will simply get 0. Both of them destroyed. Simply return. What if right health is left incoming element, which is coming in the stack, trying to encounter the stack? What if its health is more? If its health is more, firstly, if the left element incoming, its health is more, its health will get impacted by 1, and the top element of the stack, which is the right element, its health will become 0. It's gone because you have already removed from the stack. It's gone. But still, the loop will keep on going because this left incoming element, it can impact the remaining right element of the stack also. So it will keep on impacting until it can impact my stack. And that is how it will just keep on impacting your stack as much as it wants. Ultimately, I have to return my answer because it just goes on to every position and just encounter, okay, what can happen with that position. Ultimately, I will have to return my answer. I return my answer in the same order of what I have my health, because my health is in the order of my position itself, and I need to return in my positions order itself. So I return the answer in my health order itself. So my health order is nothing but X. Now I will return only push in my answer only when I have some health left. If the health is 0, it was already destroyed. For destroyed stuff, I don't count the health. So I can only push in my answer only when the health is something. And that's how I can simply return my answer. That's how you can simply solve this problem. I hope that you guys got it. If yes, can we please smash that like, baby? My throat is legit gone. We will end the stream soon. But before that, can we please reach like to 60? Just 2 more likes. That would be super great. Let's quickly jump on to the chat itself, but yeah, before that, if we can reach like 60, just 2 more, that would be super great. And I am dead, so I will quickly end the stream right here itself. But yeah, if anyone have any doubts, any problems, any issues, although the problem 2 was the only tough questions, 1, 3, 4 was kind of easy ones. 4 was a bit implementation heavy, but still like not that much heavy. But the implementation wise, I can say it's a bit in that category. But logic wise, it's pretty standard and easy. So that's one thing. But yeah, cool. Thank you so much for watching in. Thank you so much for turning in. Thank you so much, Prajwal. Thank you so much, Shlok, Dependable, Ikansh, Prabita, Ikansh, Praneet, Code Note, Faizan, Rajdeep, Tech Advice, Rohit. Thank you so much, everyone. Before leaving, if we can reach the likes to 60, that would be super great. Cool. Bye bye. See ya. Goodbye. Thank you so much for turning in. Have a nice day. Cool. Bye bye. See ya. Goodbye. Cool. Thank you. Bye bye. Please like 60.